Hello students, I think you are fine. Now today I am going to start with convolution. So what is convolution? To learn that, let's consider a signal. Let's say x of n is equal to, so x of n starting from 0 has two value, 1 at 1 and at 2 it is having 0.5. Then this x of n signal can be represented as, in the form of impulse signal, the x of n can be represented by x of n is equal to 2 into del of n plus del of n minus 1 plus 0.5 into del of n minus 2. So altogether it can be written as summation k from 0 to 2 x of k del of n minus k, as the signal runs from 0 to 2. If it is running from minus 1 to 3 or in whatever the range, so we need to take up that range. Now, what is convolution? So in convolution, we consider a signal x of n applied to some block. Let's say the transfer function of that block is equal to h of n. Then the output y of n is equal to x of n star h of n. The star is nothing but the convolution operation. So let's learn it in detail. y of n is equal to h of n. Y of n is equal to h of n y of n is equal to the transfer function operated over x of n. The transfer function operated over x of n. H, when I substitute the value of the x of n, then it becomes that x of summation k running from minus infinity to plus infinity, x of k del of n minus k. In generally, the x of n signal can run from anything, not restricted to like 0 to 2 or anything. It can run from minus infinity to plus infinity. So if x of k, like if transfer function is operated on this signal, then let's take the summation outside. So summation k from minus infinity to plus infinity, x of k, h of the transfer function operating over del of n minus k, the impulse. So y of n is given by k running from minus infinity to plus infinity, x of k, h of n minus k, wherein h of del of transfer function operated over del of n minus k is nothing but h of n minus k. And in turn, this can be written as x of n convolution h of n. Of course, star is a convolution operation, convolution operator. Now, what is this convolution? Is a multiplication or what is exactly? So to understand this convolution process, or how does it exist, how it can be computed, for that let's consider an example. Let our x of n signal, our input, the same one which we have seen at the top, like 0 to 2, it is running with the same values to 1.5. Then h of n. In convolution, we need two signals. Convolution happens with two signals. So we need the transfer function signal also. Let's say it is h of n. And h of n is equal to, let's say it is in this way, running from -1 to 1. So having the values like 1 at all these places, 1 and even 1 over here. Okay, so the operation will be given by the same equation. Y of n is equal to summation k from -infinity to +infinity x of k h of n minus k. So here the k is nothing but the range of x. Generally we have taken it from -infinity to +infinity, but here our x of n is running from just 0 to 2. So let me expand. Let's take the equation for convolution. Y of n is equal to summation k running from 0 to 2, as our signal runs from 0 to 2. So it is x of k h of n minus k. If I expand this equation, the expansion of this equation becomes x of 0, like when I put k as a 0, x of 0, and as k is a 0, it becomes h of n. So x of 0, h of n plus x of 1 when k is 1, h of n minus 1 plus the next value x of 2 and h of n minus 2. Now these x of 0, x of 1 and x of 2 are nothing but the values taken by our x at the 0th instance, at the first and at the second. And they are x of 0. X of 0 of mine is 2, x of 1 is 1 and x of 2 is 0.5. So this becomes x of 0 is 2, so 2 h of n plus x of 1 is 1. So it is h of n 1 into h of n minus 1 plus x of 2 is 0.5, so it becomes 0.5 into h of n minus 2. Then we need to go for the calculation of this. Okay, so to find this y of n, first we need to compute 2 h of n, the second one h of n minus 1 and the third, and we need to add them all together. So 2 into h of n. So we know that 2 and h of n is the same signal running from -1 to 1, and as we are multiplying 2 with h of n only, so h of n remains as it is. So all samples are 1 and runs from -1 to 1. So 2 into this. We know how to multiply 2 with this signal. So when we do multiplication, the resulting signal is so. So each of the sample gets multiplied by 2. So 2 at -1, at 0 and even at 1. And it is not our output, it is a part of our output. So let's name it as y1 of n. Then we need to go for second. 1 into h of n minus 1. 1 into h of n minus 1. 1 multiplied with h of n minus 1. H of n minus 1 we know how to compute. H of n minus 1 is obtained by time shifting the h of n signal by 1 unit to the right. So h of n minus, I hope we know how to find h of n minus 1. So as this 1 is positive, the h of n is shifted by 1 unit to the right. So it runs from -1 to 1 here in h of n. So in shifted version, it runs from 0 to 2. So the same h of n minus 1 signal multiplied with 1. So when we multiply, the values of the samples remain as it is 1, but their places get shifted from like 0 to 2. So this is our second intermediate output. Now, the third one we need to calculate, that is 0.5 into h of n minus 2. 0.5 into h of n minus 2 is obtained in this way. 0.5 into 0.5 into h of n minus 2. h of n minus 2 is obtained by time shifting the h of n signal by 2 units to the right. So h of n runs from -1 to 1. So here it runs from 1 to, it runs from 1 to 3. It runs from 1 to 3. Okay. So I hope you understand this. Then the multiplication of this h of n minus 2, h of n minus 2 signal with 0.5 will result into all the samples with of amplitude of 0.5, but that places of course running from 1 to 3. Now this is our third intermediate output. So we had only 3 samples with our x of n signal, with our x of n signal. So we'll have only 3 sub intermediate outputs. So at 0, 1, at 0, 1 and 2. When we add them all together, like y1 of n, y2 of n and y3 of n, we get, like, we need to add them at particular values like n is equal to -1, n is equal to 0, n is equal to 1, 2 and 3, like this. When n is equal to -3, its value exists only in the first output, so which is -2. So at n is equal to 0, in y1, y2 and y3, in y1 it is 2 and in y2 it is 1 and in y3 it doesn't. So its value is 3. At n is equal to 1, in y1 it is 2, in y2 it is 1 and in y3 it is 0.5. So its value becomes 3.5. So similarly at 2 and 3, the values can be calculated and the resulting output is this. And this output y of n can be given by, so we can write it as in the form of an impulse signal 2 into del of n plus 1, as it starts at -1. Then plus 3 into del of n plus 3.5 into del of n minus 1 and so on. Up to 3 the signal is running. So this is the result of convolution. So convolution is a sort of multiplication, but not like the same, not like just multiplication of 2 signals. The one of the signals, each of the value, each of the sample value gets multiplied with another signal, but even with a time shifted version of that another signal. So I hope you are understanding this way and try to calculate or try to solve the different problems of this type. Thank you.